Good morning, everyone, and welcome to this lecture. This is lecture number 8 in Center of Mass, and we are dealing with in this class impulse. I think we have already dealt with impulse in the previous classes. I think in the chapter on Newton's law, we have dealt with impulse. Did we deal with impulse? Have you heard the term impulse? Have you heard the term impulse, beta? Yes or no? Have you heard the term impulse? Am I there? Am I audible? Am I visible? Have you heard the term impulse? Yes or no? Is that a yes or a no? Tell me. Have you heard the impulse? No? Oh yes? No response. No response is the worst response in the universe. If you don't give any response, that means anyways. Impulse. Am I audible? Am I visible to all of you? I'm not able to understand whether I'm audible or not.
Sir,
Say something. Now when I ask you something, say. Don't keep your mouth shut. Otherwise, I don't understand what is happening in the class. And that becomes a problem. If I don't understand what I'm saying, I will not be able to do anything. Impulse of a force or impulse denoted by the letter I. How do I define this impulse? Impulse is defined as, if no one knows it, impulse is defined as the integral of force with time. You integrate force with time, you get impulse. Impulse vector is integral of f into dt. From here I can also write impulse will be integral of force is m into a into dt. A can be written as m into dv by dt into dt. So it becomes the integral of m into dv, or it becomes the integral of dp. Impulse becomes integral of dp. It becomes the change in momentum. Impulse of a force is equal to change in momentum. This theorem is known as the impulse momentum theorem. Impulse momentum theorem. Impulse is final momentum minus initial momentum. This statement is known as the impulse momentum theorem. Impulse is a vector quantity. Impulse is a vector quantity, and the direction of this vector is same as the direction of force or the direction of change in momentum. SI unit is same as change in momentum or force multiplied by time, Newton second. I'll give you 2 minutes to note it down. So then let's move ahead. If we have a graph between force and time, remember integral means area under graph. If I have a graph between force and time, impulse will be the area under this graph. If I have a graph between force and time, which is here, impulse will be the area under this graph, or this area will be equal to change in momentum. So impulse the area under FT graph. Note it down. Noted this, everyone? So then there is a question that you have to do. This one, the hero of a stunt film fires 50-gram bullets from a machine gun, each at a speed of 1 kilometer per second. If he fires 20 bullets in 1 second, what average force does he exert against the machine gun during this period? So you have to find out the force that he exerts. I'll give you 2 minutes. Let me know once you are done. So how are we supposed to do this? We just have to find out the change in momentum. And how will you find out the change in momentum? Everything is given to you. You know the change in momentum. From change in momentum, you will get the impulse. From impulse, you can find out the force. So what is the change in momentum? One bullet is 50 grams. So 50 into 10 raised to the power of minus 3. It is the mass of one bullet. 1 kilometer per second. So it is 1 into 10 raised to the power 3 meter per second. That is the change in momentum of one bullet. 20 bullets. So multiplied by 20. That is change in momentum. that must be equal to force multiplied by time. So force acting on the force that the man must exert would be equal to 50 into 20 divided by 4, and that is your answer, 250 newtons. I'll give you a minute to note it down. Everyone has understood this? Why you always raise hands, but I don't get any answer. There is no use of raising hands when you can't give an answer, beta. Does not make any sense if you raise hands and don't give me an answer. It's a simple question. You just have to find out momentum change and then divide it by time. It's taken too long and then you don't respond. That does not make any sense. Anyways, this is the next question. A sphere of mass m is moving with a velocity which is given. Then it rebounds back with a velocity which is given. You have to find out the impulse that it receives. I'll give you 2 minutes. Please tell me the answer. So basically what you have to find out is simply impulse. Impulse vectorly is nothing but final momentum P2 minus P1 initial momentum. Just have to find that one. Multiply velocity with mass and you get your momentum. So impulse is m multiplied by V2 is I plus 3j minus 4I minus j. So that is your answer, whatever you get from here. And I think what you are getting from here is m into minus 3I plus 4j. So that is the answer that we were looking at. Impulse is nothing but change in momentum. I hope that point is clear to you. Impulse. Now, the next heading that we are going to do is known as an impulsive force. So the next heading that we write is impulsive force. Impulsive force. What do you mean by impulsive force? Anyone has any idea? What do you mean by an impulsive force? Yes, anyone would like to say anything? What do you mean by impulsive force? Any force that creates an impulse is an impulsive force. Any force which changes the momentum of a body is an impulsive force. Any force which changes the momentum is an impulsive force. But whenever we are talking about an impulsive force here in this particular chapter, we are talking about a very special kind of force which we are going to call as impulsive force. A force which is of a very large magnitude and acts for a very, very short interval of time, that force will be caused as impulsive force. So an impulsive force is a force of very large magnitude acting for a very short time. An impulsive force changes the momentum. An impulsive force changes the momentum in a very short time. Now remember, this is just a term that we have created. All the forces, if you say they are impulsive, there is no boundary between what is an impulsive force, what is a non-impulsive force. But from now onwards, whenever we use the term impulsive force, we will imply only those forces which are of very large magnitude and acting for a very short interval of time. We will call those forces as impulsive forces. Do we understand this? Impulsive forces are those forces which are of very large magnitude acting for a very short interval of time. Note this down. Impulsive forces, forces of very large magnitude acting for a very short duration or interval of time. Those are impulsive forces.
Done, sir.
Now, there are certain points that you will have to remember about impulsive forces. Whenever there is a sharp impact, a ball hitting a bat, a hammer hitting a nail, a truck hitting a wall, whenever there is a sharp impact, the forces during an impact forces during an impact are basically the best kind of impulsive forces. So impact forces are impulsive in nature. Whenever we have an impact between two bodies, then the forces that act between the two bodies can be called as impact forces, and these forces are always impulsive in nature. Now, these impact forces are always action reaction forces, so they act on both the bodies. These impact forces or these impulsive forces are action reaction forces. That means equal and opposite force will act on the two bodies. What do I mean by this? If I have two bodies, here M1 and here M2, this is moving with a velocity V1, this is moving with a velocity V2, they are going to collide. They are going to have an impact between each other. Now, body 1 will exert impulsive force on body 2. Body 2 will also exert an impulsive force on body 1. What will be direction of impulsive force exerted by body 1 on body 2? Anyone? They collide like this. What will be the direction of impulsive force acting on body 2 by body 1? Yes.
Opposite side.
Which opposite side? Right, left? It will be in this direction that the impulsive force will act. I. This impulsive force will act on body 2 because of impact with body 1. Body 2 will also exert the same impulsive force on body 1, same in magnitude but opposite in direction. Same in magnitude but opposite in direction. So that is what you must always remember. Whenever there is an impact, the forces acting between the bodies, the impact forces are always impulsive in nature. Now, when there is an impact like this, gravitational and spring forces would also be present. But we will see that this gravitational force and spring force are not taken as impulsive forces. They are always non-impulsive. So whenever there is a sharp impact like this, what has happened just now, we can neglect these gravitational force and spring force because they are not going to create that much of an impact. They are not going to create that much of an impact. So that is the next point that you must remember. Gravitational force, spring force are always non-impulsive. Then what forces are impulsive? Then whatever is remaining are all impulsive forces. Normal reaction, tension, friction, all these are impulsive forces, but they are also case dependent. Sometimes they are impulsive, sometimes may not be impulsive. We will see the case when they are impulsive. We will also see the cases where they may not be impulsive, where they are not impulsive. But whatever happens, gravitation and spring force are always impulsive. The last point, most important one, an impulsive force can only be cancelled by another impulsive force. If you have to balance any impulsive force, it can only be balanced by another force which is impulsive in nature. Normal forces cannot balance an impulsive force. Normal forces like gravity and spring force, which are not impulsive, cannot balance these impulsive forces. So that is what you must remember. That is what you have to understand about these impulsive forces. Impulsive forces are forces of large magnitude acting for a very short duration of time. Gravitation and spring forces are not impulsive. Have you noted this down? Yes or no? Okay. Note it down fast.
Done, sir.
So this is a small question that you have to um, tackle here. A ball of mass 2 kg is falling on a floor ground with a velocity of 5 meter per second. It rebounds back with the same velocity, and the time it remains in contact is 0.001 second. So it remains in contact with the floor for 0.001 seconds. Then it rebounds back. What is the impulse given by gravity, gravitational force? And what is the impulse given by n? Do we understand? Do we know what is this n? This n is the normal reaction, so you have to compare What is the impulse given by gravity and what is the impulse given by this normal reaction? I will give you 2 minutes to give me the answer. So this is the question that we are going to do. Impulse is given as a function of force is given as a function of time. You have to give me the value of impulse. So this question just requires a bit of integration. I don't want you to get stuck with that integration. I will create the integral and then you can put the values. The impulse is nothing but integral of f into dt. I hope all of you understand this. So I just need to integrate this. Integrate what? So impulse would be the integral of 3t square dt I can keep them separately minus so 3t square minus dt 3t square dt I minus I can use the integral 2t minus 1 into dt j plus 2 times dt of k. I just have to integrate it from 1 to 3, from 1 to 3, from 1 to 3. So what will I get here? I will get 3t cube by 3 integration from 1 to 3 with I minus here I will get 2t square by 2 minus t. I have to integrate it from 1 to 3 and that will be with j plus 2 times t. I need to integrate it from 1 to 3 with k. Do we understand this? The final answer that I have is something like this 26 I minus 6j plus 4k. So you can check your answers. You can do this calculations at home. You can do that, yes or no? Everyone has understood this? How to do this? How to find out impulse? Okay. This one. How will you solve this question? It's a very simple one. And I hope you can give me the answer. A 1D force F varies with time according to the given graph. So a graph is given to you. Calculate the impulse of the force from 0 to 10, from 10 to 15, and from 0 to 15 seconds. So they're broken up into two parts, I guess. And they're asking you the impulse from 0 to 5. So 0 to 10, 10 to 15, and 0 to 15 seconds. You have 2 minutes to give me the answer for this one. So how are we supposed to do this? To find the impulse from 0 to 10 seconds, we have to find the area of the FT graph. The area of FT graph is this area. This is the pink one. And this is the green one. Now you can find it out as pink one or green one, or you can find it out as area of the trapezium. Doesn't matter how you do it. Is the one and the same thing. Do we understand this? Yes or no? So what is the area of this part? Complete area of this part?
25 Newton.
75 Newton second. Yes or no?
Yes, sir.
I will call it plus 75 Newton second because it is on the above the x-axis. Then you have to find out the area of this part.
That's 25 Newton seconds.
It is 25. I will call it minus because it is below the axis. Yes or no? So the total impulse from 0 to 10 seconds is plus 75. From 10 to 15, it is minus 25. From 0 to 15, it becomes plus 50 Newton seconds. Do we understand this? Anyone understands it? Everyone has understood what we have done in today's class? In today's class, we had seen what is an impulse. We had also seen what happens during an impact. Impact forces or impulsive forces, they start to act. The next class, we'll continue on this and then move on to the most important aspect of this chapter, which is collision. So probably in the next class, we will start with collisions. Again, slight warning, please do revise what we have done in the previous class. Otherwise, in the next class, you will not be able to understand much. So I hope that you come to the next class revising what we have done today. I will take leave and I'll dismiss the class here. I'll see you in the next class tomorrow. Take care. God bless all of you. Bye bye.